Hello and welcome to another episode. This one was asked on my stream, yesterday? I don't know. I think it was yesterday. But the question was, what is TDD? What is test-driven development, and do you do it, and how do you do it? So we'll jump into that today. And so the basic idea behind test-driven development is that you write your tests first and force yourself into writing simpler code, or at least that's how I like to think about it. Another way is that you kind of describe your behaviors before you go about implementing them. I'm going to show you an example of the example procedure for test-driven development, and then we'll talk later about whether I actually do it all the time and when I think that it's probably a bad idea. But yeah, let's start with So part of the thing with test-driven development is you switch back and forth between writing tests and running tests, and writing tests and running tests. Or I guess writing tests, writing implementation, then running the tests, or somewhere around there. But I'll show you how I approach it. So let's just open up a Python file. Maybe I didn't. Did I install pytest? Nope. Okay. I'm going to install pytest. This is a testing framework for Python. The testing framework that you use doesn't really matter here. You can basically do test-driven development with any sort of framework. And for the sake of example for today, we're going to be using a function that I had to write for my text editor called parse color. And we're going to implement a simplified version of it today. It is going to take in a string and return a 3-tuple, so three integers. The string is like a hex code string, and we're going to return red, green, and blue. I do believe py.colorsys. I believe there is a module that already does this in Python, maybe? Oh, maybe not. I thought colorsys had a parser for that. But I guess not. Anyway, it doesn't matter. We're going to be implementing one of those today. So what I usually start with is just the very most basic function signature that you're going to implement. This is even maybe slightly outside the bounds of TDD. Usually you would even write the test before you write the signature, but I find that that's a little bit silly. So let's write our parse color function first, and we're going to write our very first test. And this is kind of the idea behind test-driven development is you write your tests first. And so let's just do a very simple test. Assert parse color, and we'll use the hex code 000000, which is black, and we should expect that to be 000 when we parse it. And so this is our very first test. And so then once you've written a test, you go to run the tests, verify that they're failing before you run or before you start implementing code. It's important to make sure that they're failing. That way you know that your test is kind of a useful test. It's demonstrating some behavior. So if we do pytest t.py, of course it's failing because I haven't run anything, and you'll see that parse color is returning none, and none is obviously not 000. The next step after you have a failing test is to modify your code in the dumbest way possible that satisfies the test. This is to try and ensure kind of simplicity of your tests and that you cover enough cases in your test. So my devil's advocate solution to my current failing test is to just always return 000. Now this is obviously wrong, but that's kind of one of the points of TDD. It's it forces you to say, oh, well, I could have a really silly implementation of this function that's clearly wrong, so obviously I haven't tested this well enough. And so once you have that working, then you might step to another test where you're okay, well, I need to write some other test that forces this implementation to be wrong. So maybe I'll do test whites and do that next. Do assert parse color, get our FFFFFF in there, and that should be, 255, 255, 255. I'm going to use hex literals just because it will be easier to understand in the test. Now, I could have also written, 255, 255, 255, but I like to keep my tests reasonably readable that, oh yeah, as a human reading this test, I can easily verify that this assertion is correct. Because it definitely should be OXFF because we're taking a hex and that's unrelated to TDD. That's just my thoughts about testing in general. But you'll see now that because we added this test, we now have a failing test again. So now we'll go back to the implementation and try and implement this properly. Now at this point, we're kind of forced to actually implement the code here, so we'll actually have to make it correct for these two cases. And I believe the simplest solution to that is to actually just return the right values. And we can do that by slicing the string and using the int function. So we can do return int s 1 to 3, and then int s, although we need to do it in base 16, s3 to 5, and also in base 16, and then int s 5 to 7 in base 16. Base 16, base 16, base 16. So this should make our test pass now. And cool, that's kind of our first like iteration of test-driven development. And you might be done here. My implementation actually had additional use cases that I needed to handle later. So maybe this was all I needed in the first pass, so I committed this, pushed it, and it was working fine in my use cases. But then I tried a different theme, and the theme specified colors slightly differently. And I think that's where I use TDD the most, is like when I find a bug, I write a test which demonstrates the bug, and then I fix the bug. I think that's the most useful case for it. But let's presume that I ship this as is, and someone was like, oh, well, it doesn't work for shorthand hex codes. Can you fix it, please? And I would be sure. I would be like, sure. Let me understand how short hex codes work. Well, actually, I know how they work for 000. I'm not quite sure. Like, I forget if this goes to 909090 or does it go to 999999? I don't remember. But I do know that but the short code for 000 definitely goes to 000. So we're gonna do that one. I would probably also do some research and make sure that it does what I expect in that case. But let's 000, and if we run this, we should get 000. And I believe this test should be failing, and this is the important part. You should always make sure that your test fails first before you try and fix it. Yeah, we get a crash here because we're slicing out of bounds of the string, and the empty string is not a number. So then what we would do here is we would go to our function, and you would probably special case based on the length here. So you would say maybe like, if len of s is equal to 7, then we would do this. If len s is equal to 4, we would do some other case. So that's what this case is here. And I find that when I do one of these like if branches based on the length, I always leave another case that's like raise not implemented error, or raise value error might be an okay one. Unknown color format s. And I would probably also write a test for this value error. Now, of course, like this is a behavior, so if you were going true TDD, you would probably not implement this value error, then write a test that says it should raise a value error, and then uncomment this code. But I'm gonna skip ahead here because it's clear enough to me. But anyway, not true TDD. I'm cheating a little bit. It's fine. But let's see. If len of s equals 4, we do return int. And I'm multiplying a string here, not multiplying the integer. This doubles the string. I think that's how this works. I always forget, though. Int s2 times 2, and int s3. That's a 2, not an s. So this should satisfy, this should satisfy our test cases here. And anyway, you can kind of see how I would expand out further from that. Now, if you were watching my previous pytest video, you would see that we can probably simplify these functions a little bit because they're a little bit repetitive right now, but we can use parameterize to make this a little bit simpler. Input s expected. So we can kind of build a table test for these particular cases. F. And so you see I'm building a table of inputs and outputs here. And that actually makes these tests a lot easier to write. I don't have to write out a full function and run the same assertion over and over. And in my actual implementation, I had to handle some other things too, like named colors. Test parse color input s expected. Parse color input s equals expected. And then I can delete all of that code, and we basically have the same set of tests here. Now again, I probably would have done this before implementing it, but Fine, because it's also good to like go back and verify that these tests are still being important. So like if you were to comment out these, oh boy, I really need a keyboard shortcut that comments things out in my text editor. I have not implemented that yet, but yeah, you can see like they still kind of fail, and if we make the shortcode one fail, now we only have one failing test, and then if we were to do this, so kind of reverse TDD. But let's talk about when you should probably apply TDD. I find that it makes the most sense when you know exactly what you want to do, and you kind of have an idea of how you want to do it. Or you're in a bug fixing situation. I think it's really, really good for bug fixes. But I think it's not a good idea if you don't quite know how you want your program to be designed, because it can often constrict you into an interface that makes it really hard to refactor later. Or your tests are like way too specific about your implementation. But that's just my opinions there. A lot of times when I'm building something from scratch, I will write out a prototype of the code first, and then write some tests around the behavior of the code, often leveraging tools like coverage or mutation testing to figure out whether I'm actually, validating all of the edge cases of things, or property-based testing. That's another one as well. Anyway, hopefully this was helpful. If you guys have additional questions or stuff you want me to explain, leave a comment below or reach out to me on my various platforms. But thank you all for watching, and I will see you guys in the next one.